This video introduces the hyperbolic functions. We define 6 hyperbolic functions. The first one is the hyperbolic sine function, which you write as sin h x, hyperbolic sine x. It's also called shin x. This is defined as e raised to the x minus e raised to the negative x. All of that's divided by 2. The second hyperbolic function is hyperbolic cosine x, which you write as cosh x. This is also read as cosh x. The definition of hyperbolic cosine function is e to the x plus e to the minus x. All of that's divided by 2. And then we define hyperbolic tangent, spelled tanh x. This is read as tan x. The function tan x is defined as shin x over cosh x. Tan x is equal to hyperbolic sine x divided by hyperbolic cosine x. These are the main 3 hyperbolic functions, but also we can define their reciprocal functions. So this is how the reciprocal functions are defined. We define a hyperbolic cosecant function, which is spelled as csch x, cosh x. This is defined as 1 over shin x, 1 over hyperbolic sine x. Then we define shesh x, hyperbolic secant x, which you write as sech x. It's read as shesh x. This is defined as 1 over cosh x, 1 over hyperbolic cosine x. And the last hyperbolic function is cot x, spelled coth x. Cot x is defined as 1 over tan x, 1 over hyperbolic tangent x. These are the 6 hyperbolic functions. We also have a very important Pythagorean equivalent identity for hyperbolic functions. Now we will look at that. As you saw earlier, hyperbolic sine x was defined as e to the x minus e to the negative x over 2. If you square this function, what will you get? It will be hyperbolic sine squared x, and that will be equal to, I will need to square all of these. When I do so, the denominator is very straightforward. It's going to be a 4. How do you expand the numerator? The numerator can be expanded using a minus b everything squared relationship. That's from college algebra. You know, this is going to be equal to a squared minus 2 times a times b plus b squared. So your a is e to the x and your b is e to the negative x. Then you can see a squared should be equal to e to the x times e to the x. When you multiply 2 things with the same base, the exponents are added. Therefore, e to the x times e to the x is simplified to become e to the 2x. And then the middle term. The middle term is negative 2 times a times b. So here's that negative symbol. 2 times a is e to the x, b is e to the negative x. When you multiply these 2 things, we know that the exponents are added. Then e to the x and e to the negative x will be added to become 0. It will be 2 times e to the 0. Any number raised to the 0th power is equal to 1. Therefore, this is going to be equal to 2 times 1 equals 2. So the middle term is negative 2. And then the last term is plus b squared. b is equal to e to the negative x. E to the negative x squared means e to the negative x times e to the negative x. In the multiplication, the exponents are added and it becomes e to the negative 2x plus e to the negative 2x. That's your shin squared x. Now, the same way we will look at cosh x, hyperbolic cosine x. We defined that function as e to the x plus e to the negative x. All of that's divided by 2. From that, I can obtain hyperbolic cosine squared x, cosh squared x. Just like earlier, once again, I have to square all of these things. When I do so, the denominator is once again very straightforward. It's going to be a 4. The numerator, you can expand it using a plus b everything squared. they're going to be equal to a squared plus 2 times a times b plus b squared. Just like the previous discussion, a squared will be e to the x squared, which is going to be equal to e to the 2x. The middle term is plus 2 times a times b. It will be plus 2 times e to the x times e to the negative x, which will be simplified to become just a positive 2. And the last term is plus b squared. b is e to the negative x. That squared is e to the negative 2x. Now we have everything necessary to identify the Pythagorean identity for hyperbolic functions. Now consider cos squared x minus sin squared x. This is going to be equal to, right here I have cos squared x, and right here we have sin squared x. I need to subtract sin squared x from cos squared x. You can see that they both have the same denominator, therefore I can just pay attention onto the numerators. E to the 2x and e to the 2x will be cancelled off. E to the negative 2x and e to the negative 2x will also be cancelled off. Right here with cos squared x I have a plus 2. That minus with sin squared x I have a negative 2. That will be simplified as the common denominator is a 4, and then I have 2 minus negative 2. That simplifies to become a 1. Therefore, this is the very first Pythagorean identity for hyperbolic functions, which is hyperbolic cosine squared x minus hyperbolic sine squared x is equal to 1. It's a very important relationship in hyperbolic functions. Let me box that one. Let me label this relationship as relationship number 1. What I'm going to do next is this equation number 1, I'm going to divide that by hyperbolic cosine squared x. When I do that, the first term is hyperbolic cosine squared x divided by hyperbolic cosine squared x, which is just a 1, minus the second term is hyperbolic sine squared x. When that's divided by hyperbolic cosine squared x, that term becomes hyperbolic tangent squared x. On the right hand side, I need to divide 1 by hyperbolic cosine squared x. When I do that, it will become a hyperbolic secant squared x, sec squared x. This is the second of the 3 Pythagorean identities for hyperbolic functions. Let me label that as equation number 2. Just like that, I can once again look at that first equation and divide both sides of that first equation, this time by hyperbolic sine squared x. When I do that, the first term is hyperbolic cosine squared x. When that's divided by hyperbolic sine squared x, I get hyperbolic cotangent squared x, cot squared x. That minus the next term is hyperbolic sine squared x. That has to be divided by hyperbolic sine squared x, which becomes just a 1. On the right hand side, I need to divide 1 by hyperbolic sine squared x. When I do so, it will be 1 over hyperbolic sine squared x, which is hyperbolic cosecant squared x, which is cosec squared x. That's your third Pythagorean identity for hyperbolic functions. Alright, that's the small introduction to hyperbolic functions. In the next video, we will see how to differentiate the hyperbolic functions. Thank you.